Before I start us on the scientific program for this morning, I want to introduce Kate Matthias, who's here from NAMI, Connecticut, to say a few words of welcome. We're very appreciative of the partnership over the decades from NAMI, Connecticut in putting this event together.
Good morning. As I thought about what I wanted to say this morning, brief remarks, I want to echo some of what Dr. Crystal just said. As a former family member and as somebody who works with and is responsive to family members and individuals living with mental health conditions, what I know is that research is important to them. The research that's already produced drugs and other interventions that can help people is so well regarded, and there's always hope if there's research. And so I really want to commend everybody involved here today, everybody who's involved in the research here at Yale. It makes an enormous difference in the lives of people. So I just want to say that. I want to, on the part of NAMI Connecticut, to welcome everybody here today. It looks like a wonderful program, and I am always honored to be here at this research conference. So thank you very much.
Thank you very much, Ms. Matthias. Thank you for being with us this morning. So now it's my great pleasure to set up the scientific portion of our talk. So we're going to have of our symposium. Thank you. So we're going to have 4 exciting talks this morning, and as Dr. Crystal has introduced, there's a lot of really exciting research going on here at Yale, and has been over the decades. Research that gives us fundamental insights into how the brain works, into how it goes wrong in some cases in a mental illness, how it just differs in cases where you can't really say it's going wrong, but it's out of balance in ways that give people unique challenges in their lives. And then how those insights can translate into new treatments. And one of our goals at the conference this morning is to take some of those exciting insights and convey them to all of you. And we've got a great lineup of speakers to do precisely that this morning. Our first speaker is Dr. Vijita Sinha. Dr. Sinha is the director of the Division of Psychology within our psychiatry department here at Yale, and over several decades has done really groundbreaking work in the effects of stress on the development of substance abuse, as well as on many other aspects of substance abuse and how to treat it. So, Dr. Sinha, thank you for joining us this morning.
Thank you so much. It's a real pleasure and honor to be here this morning to speak with you all. Let me get this going here. Great. So I'm going to talk about recovery from addiction. One of the things that we know is that there are treatments that can get people to stop using substances acutely, meaning in a short period of time. And as Dr. Crystal pointed out, there are some that were developed right here to initiate alcohol abstinence, for example, to help with opioid detoxification. But one of the big challenges in addiction and in treatment of addiction, which a number of you have experienced and heard about, is relapse and recovery, the idea of breaking the cycle. And so one of the things that we wanted to do was really start to understand what is going on there. Why do we have this problem? What you see here on the screen are data from our own outpatient addictions clinic that's part of the Connecticut Mental Health Center. And this is just from 1 year data. And what you see, let me see, I don't see a pointer here, but maybe I can point from here. Yep. Are people using cocaine, marijuana, opiates, alcohol meeting criteria for addiction for those substances. They could be using multiple ones, but primarily identifying with each of those. And the colors show essentially the time in treatment and time to relapse. So on the y-axis here, you see when the proportion that remained abstinent. And it doesn't take much to figure out that these curves are dropping down, right? So what you see here is people initiate treatment and they're doing fine, meaning that they are ready to commit to recovery and abstain or cut back. And over time, what we see is that things are the typical phrase of falling off the wagon, that begins to happen. And it's no surprise we have medications to treat alcohol, we have medications to treat opioids. So within the first 90 days, there's a separation between cocaine and so stimulants and cannabis, but not for opiates and alcohol. There's a better response rate with those medications. But we do know that over time, there's these relapse rates fall below 50%. So this was a big challenge as I started my career treating addictions and leading the substance abuse treatment unit. And I wanted to understand relapse and recovery. It's a highly common phenomenon. I've just shown you data on that. People, if you ask people what led to relapse, they'll tell you all kinds of things. Stress led me to a relapse, my negative mood, I was really bored, people, places, and things. I got tempted, so there were high cravings. So there are lots of multiple things. How can we begin to understand this? What leads to a specific lapse or relapse? Across episodes of recovery can be really different, even in the same individual. And of course, they could be different across individuals. So this is a major challenge. And for a long time, people said, well, we're going to develop treatments that can initiate this, but you really can't, recovery is a lifelong process, which it is, but we can't really get a handle on it. We started to say, wait a second, people who are struggling with this, though, learn all kinds of coping skills. They want to really, they work their recovery really hard, and still, when they get out there, I would have some of my individuals who were at our clinic saying, I don't know what happens to me when I'm out there, I just get back to using. And so we really wanted to start understanding that. And so we said, what if we can actually begin to understand that? What would be the benefits? Are there benefits of understanding that? Well, we might be able to identify those who are most at risk for relapsing. And if we're able to do that, we can actually start to target our treatments and really get to what now has become a movement really coming from cancer research, that there is personalized medicine, that we can actually target treatments based on people's vulnerabilities or based on how drugs have actually affected their brains. As you heard, it is mental illness is a set of brain disorders, and addiction is no different from that. What we do know is chronic drug use will lead to changes in the brain, but most importantly, first, individuals will feel it as behavioral and mood changes. What are some of the things that we know very clearly those who are struggling in early recovery will talk about is drug cravings, very high levels of drug cravings, very quick in responding impulsively to drug-related stimuli. There's a lot of increased stress, anxiety, irritability, sleep problems, cognitive problems. And we know now that in association with these behavioral symptoms, there's atrophy in the brain, so there's some reduction in brain volume, in particularly our gray matter regions where our nerve cells are, and there's altered stress biology. And this is what got me really interested in understanding the connection between stress, both biologically and environmentally, and its impact on addiction recovery. And lots of biological chemicals related to the stress response are altered in early recovery and altered with chronic drug use. The CRF system, our fight or flight response, is altered. So we have high heart rate basally. The biological systems that control that high heart rate to bring it down are altered, are not functioning well. We have other chemicals that are involved in the fight or flight response that are altered. And most importantly, importantly, the frontal part of our brains that are involved in regulating our stress response and regulating our impulses are altered. And I'm going to show you some data on that. So let's go to drug craving. Over the years, what we began to do was do experiments in the laboratory, actually on the clinical neuroscience research unit, on the Ribicoff clinical side. And what you see here are just by inducing, reminding, and having people imagine their drug-related stimuli while they were inpatient, so they were in a protected environment, or imagine stressful situations like the ones that are that they're facing in the real world, or imagine relaxing situations. And over the years, with different groups of patients, what we see here, the healthy social drinkers are right here in the dark bars, but addicted individuals who are early in recovery, even with just 5 minutes of imagining these scenarios of the real world, start to crave. And the level of craving actually affects, when they are discharged from the inpatient unit, how they do in their recovery. It actually starts to impact their recovery process and who's going to relapse. So if you then follow them prospectively, meaning looking into the future and seeing who's going to relapse, you can see that those who had high levels of craving, just even with exposure to 5 minutes of these cues that lead to increased cravings, in fact, that measure was predicting who relapsed. And right here, the folks who are relapsing, and here are the healthy controls, and you see that these folks had the highest level of craving. Well, what about other kinds of markers? Now, I told you that the stress system is really altered under chronic drug use. And so we started to see, well, what is the process of recovery of these stress markers? Does our heart rate and fight or flight response get back to baseline, get back to homeostasis? And people were on the inpatient unit for about 3 to 4 weeks. So we thought, okay, this is a good time for us to see. Well, actually, there were a lot of individual differences in how recovery was happening. And people were not recovering as quickly as we thought. And this is just one marker here. We call it the cortisol ACTH ratio. It's a marker of adrenal sensitivity. The cortisol stress hormone gets signals from the brain. It goes to the adrenal glands, which is down in our bodies, down below the stomach, and the adrenal cortisol hormone is released, and that's called adrenal sensitivity, the sensitivity of the adrenal cortex to respond to these brain signals and release cortisol. What we know is that basally, just regular in early recovery, these are altered. And what we were able to show is that the level of alteration while on the inpatient unit predicted future relapse. So once again, we had a marker, and right here you see that those who were relapsing had higher levels of this ratio, or of the adrenal sensitivity ratio. We come now here where there is another marker called brain-derived neurotrophic factor, and this is a brain neuropeptide that is actually helps with neurogenesis or recovery and resilience, building new neurons and new nerve cells, but they're dysfunctional. This whole system gets disrupted as a function of chronic drug use. And so what we found is that even just looking at serum levels right from your blood, drawing these levels at 3 weeks of abstinence, we had substance use individuals who had very high levels. A lot of them were women, it turns out, so there are sex differences here. They tended to be most vulnerable to future relapse. So there are these biological markers that in fact are highly sensitive to recovery. Now we all know that if there's a trauma history in an individual, it tends to complicate the recovery from mental illness. For all types of mental illness, and addiction is no different. And one of the things we wanted to do was really start to see, well, what is the contribution of that kind of history, repeated childhood trauma, and we can assess that through a self-report in our addicted individuals. That's called the Childhood Trauma Questionnaire. It's a screening questionnaire that screens for different types of maltreatment, emotional, physical, sexual abuse, and emotional and physical neglect. And what you're going to see is that actually those experiences in childhood continue to have an impact on how people do in treatment during adulthood. So here you see curves, just like I had shown you right at the beginning, that in fact those who had a trauma history or early trauma history were more likely to relapse. This is day to relapse here and proportion who relapse. And you see a proportion who survive or don't relapse. And so what you see here is a much more quicker, steeper curve to relapsing or jeopardizing their recovery as a function of trauma history. And so we had actually scanned our patients who were on the inpatient unit while they were drug-free. And so we were able to say, well, just structurally, are the brain regions that are involved in the stress response contributing to this early relapse susceptibility. And what we found here is right here is the amygdala and the hippocampus. These are brain regions, the amygdala being really involved in our stress alarm system, in alerting us that we are very stressed out, there's something is not okay. And we know that under lots of conditions of chronic drug use, but also under mentally ill, active mental illness, these circuitry is not functioning well. And then there's the hippocampus, which is involved in memory. And what we found is that the volume of the hippocampus and the amygdala was lower. And when it's lower as a function of drug use, we had a higher susceptibility to relapse, as well as how severely you relapse, so how much people go back to using. What we also began to study then is what's happening, can we identify functionally when people are faced with stressors in the environment, what happens to the brain? And with neurobrain imaging techniques now, what we can do is look at measures of blood flow in different regions of the brain. So if we stimulate the brain, what happens to different regions of the brain and how is it functioning? Is it functioning like healthy individuals or is it functioning differently? And what we found is that right here in the red are our alcohol-dependent individuals who were 4 weeks abstinent. They had not been using for 4 weeks, and here are our healthy controls. And they were imagining in the scanner, just for 2 minutes, in the neutral, relaxed conditions, imagining being at the beach, listening to the waves, being at a park, maybe taking a nice hot shower, things that they have identified as being relaxing. And then they also imagined being in their very stressful situations, like having an altercation with a family member, or on the job. And what we found is that actually under the relaxed conditions, this part of the region, now your nose is over here, and so this is the front part of the brain. If you touch your forehead right here, this is in there, behind your forehead. And what we found is under the neutral relaxed conditions, the healthy folks were nicely relaxing this frontal part of the brain. The frontal part didn't have to do much, so it was sort of down-regulated. In blue, you're going to see when things are blue, it's hypoactive, and that's a good thing under relaxed conditions. But our individuals who were recovering from alcohol dependence actually had this hyperactive. And so that was a disrupted state. That was a state that was not okay. And then under stress conditions, we need our frontal cortex to mobilize. We need it to actually start to sort of figure out what to do under those stress situations and how to cope most effectively. And blue means it was hypoactive. And so what you see here is that our alcohol-dependent individuals had much lower levels of activity in the stress condition compared to our healthy controls. Well, does this matter? Does it have anything to do with the clinical symptoms that I was talking about? It turns out that that actually relates to craving. This hyperactivity makes people more reactive in stress conditions, and in drug-related situations makes them more reactive with higher levels of craving. We've shown that. And this hyperexcitability predicts future relapse. So right there, this disruption in the brain affects who is going to relapse. And what these curves are really people with different levels of hyperactivity. So we have a lot of individual differences. And those with the greatest level of hyperactivity relapse most quickly. Within 20 days, you see that their percent of folks who will relapse drops down significantly. Similarly, if your brain is not mobilizing under conditions of stress and it's hypoactive, you have a higher propensity of future relapse. So what we were able to show here is that in fact this functioning of the prefrontal system, this area right behind the forehead that's involved in regulation, I'm going to show you some data around that, is a highly sensitive region in terms of predicting recovery and relapse. And what you see here is under stress conditions, stress versus neutral, or drug-related cue versus neutral, and these are healthy social drinkers, so their drug situations are alcohol situations, going out to the bar with their friends. This is the front, the nose is over here, so this is the frontal region. Red yellow means more activation, and so you see healthy control is beautifully activating the frontal cortex under stress conditions, under drug-related situations, sort of managing, well, I think I need to stop here now, I don't want another drink, perhaps thinking about effective coping skills. And here are our non-relapsers, and here are our relapsers. Now, it doesn't take a neuroscientist, right, to figure out that something is going on over here, that there is no red and yellow over here, which basically means that we have our frontal cortex kind of hypoactive and not functioning well. So what we began to figure out is that actually there are markers. It doesn't matter what the provocateurs are that may drive you to relapse and make you put people at more risk for relapse during that early recovery period. There are these markers that are fairly common across different triggers and precipitants. We have increased anxiety, increased distress levels that predict relapse. We have higher levels of craving. I showed you a little data on adrenal sensitivity and those biological stress measures. I also showed you brain data, which is hyper-responsive during stress conditions, but has this hyper-responsive state under relaxed conditions, people who can't bring that down, as well as changes in gray matter volume. So this begins to tell us, well, can we start to target these things, these markers in specific folks who have this particular vulnerability to help them? Now, just taking a step back, I just want to orient you again to the brain and where we are. The nose is right here, so once again, right behind the forehead, we've got our hotspot, this frontal cortex that I was identifying and showing you data on, that circuitry is disrupted. Let's just take a moment and notice and see what are the functions that go on with the frontal cortex. And you can see that this particular hotspot particularly is important in actually regulating the body, what we call the viscera, the hypothalamus, the alerting signals of when we are stressed out, so our emotional reactivity, as well as our attention, our ability to inhibit impulses and things that may jeopardize our long-term goals, kind of like recovery. And so if we have atrophy in this region or disruption in this region, all of these other circuits get out of whack, particularly the emotional and reward circuitry, which is down here. What I want to do is now show you some data, move towards treatments, and see, can we start to target both the frontal systems as well as this, what we call the limbic regions, or the lower brain, the more older parts of the brain, the more primitive regions of the brain that are involved in alerting us that something is not right and we are stressed out. So there are different ways to reverse the effects of chronic substance use and really improve recovery outcomes. There's medications, there's behavioral strategies, and there are adjunct wellness strategies. So what I want to show you now is some work that we've done. This is not even published. I've been talking to you about personalized medicine. So we wanted to identify really people who are most at risk. And clinically, one of the things we know, say with alcohol as well as with opiates, is that there are withdrawal symptoms. So we've been testing this medicine called prazosin. Prazosin is an old antihypertensive drug. In fact, it's not used for hypertension much anymore. But it has been shown to actually help with nightmares. It's been shown to help with trauma symptoms in veterans. And basic science studies with laboratory animals has shown that it decreases alcohol withdrawal symptoms and also increases recovery. So it decreases alcohol intake. So we said we should try this, and others have also tried it. We also showed in a laboratory study that it decreases that stress reactivity part of the disruption that I was showing you with alcohol-dependent individuals. So we recruited both people who had high alcohol withdrawal and low alcohol withdrawal. I'm just going to show you their response over 12 weeks of treatment. Those who got prazosin, you can see that it was slow because it takes 2 weeks to ramp them up to a full dose, and they had much lower levels of a return to heavy drinking, really down to 20% compared to those with alcohol withdrawal symptoms who were on placebo, who remained at 50, 60%. So once again, we want to identify clinical markers and biological markers that make people more vulnerable in terms of their response to recovery and jeopardizes their recovery, and target those measures. We also scanned a subgroup of folks, exposing them once again to their own, very briefly, to their own stressors and drug-related cues. And just to keep you on your toes here, I'm reorienting the brain. And this is a different type of slice. The nose is over here. This is from the slices going this way. And this is the frontal part of the brain. And what we see is that prazosin, relative to placebo, is increasing blood flow and activation, bold activation, in that frontal region of the brain. So I was just showing you data that there is not frontal activation, particularly in those who have difficulty with recovery, and this medicine is actually bringing some of that back. I want to turn now very briefly to mindfulness interventions. How many people here have heard about mindfulness? It's out there, right? Great. A lot of you have. It has been, there's a self-help movement out there with mindfulness self-help strategies. You can go to your yoga studio and somebody's teaching mindfulness. Well, it turns out actually that their mindfulness strategies have been incorporated in psychological treatments. There's mindfulness-based cognitive therapy, which has been shown repeatedly now for treatment-resistant depression to be efficacious for that. And this is a paper that looked at 286 individuals who had initiated treatment for substance use disorders, and then they were randomized to standard relapse prevention, standard drug counseling, AA-based and NA-based recovery, and then mindfulness-based relapse prevention. And what they found, what these authors reported, and then they followed them for 1 year. And what you're seeing here in the blue is treatment as usual, which is your drug counseling 12-step based. In orange is relapse prevention, which is cognitive behavioral treatment, and gray is mindfulness-based relapse prevention. And y-axis just says number of drug use days, number of days that they used, and number of heavy drinking days. What I want you to see is that recovery over 12 months seems to be much better with mindfulness-based relapse prevention. So all three do pretty well at 3 months. Cognitive behavioral treatment and mindfulness do better than 12-step at 3 months. At 6 months, continuing to see some effect, but by 12 months, we see the type of treatment that has continued to help in recovery is mindfulness-based relapse prevention. This is very exciting. This is new. These are new findings, and this study was not done here at Yale, but here at the Yale Stress Center, we have been studying mindfulness and how it works, mindfulness as well as different meditation practices. What targets are being affected as a function of mindfulness? What brain targets? Can we begin to understand the processes by which meditation is actually helping? And so what we did with Judd Brewer was he ran a smoking cessation trial at our substance abuse treatment unit and showed that mindfulness training helped with smoking cessation, improved abstinence from smoking cessation. And we scanned some of those folks, again, saying, let's challenge them with stress exposure, because the best proof in the pudding, so to speak, would be how is the brain coping with stress, right? And so after 12 weeks of mindfulness training, these folks were scanned and exposed to stress, and they were people who had either mindfulness training or freedom from smoking, which is a psychoeducation-based cognitive behavioral approach to smoking cessation. Blue, remember, means it decreases activity. What you're seeing here, and this is the bar graph for this particular region, which is the amygdala region, our emotionally reactive region. And what you see here is that mindfulness training actually is decreasing reactivity in the amygdala. So not only do we know that mindfulness does improve the prefrontal circuits, it's actually helping us target two different parts of the brain systems that, of course, connect and respond to each other. And I showed you that the prefrontal systems are drooped down, more hypoactive under drug conditions, what we're seeing here is that mindfulness actually starts to have what we call bottom-up effects, or the more primitive regions of the brain, it quietens them down. So we start to see that the amygdala, this caudate, dorsal striatal region, which is our reward regions, and the insula, another emotion integration region, starts to calm down. And the level of calming down that is going on with that actually, again, has meaning that it impacts clinical outcome. The percent of reduction in smoking cessation was impacted by this reduction in amygdala reactivity to stress, both at the end of treatment at 12 weeks, as well as at another 3-month follow-up time point, so 6 months after cessation. So these are exciting findings, and really the target here then, I want to conclude by saying that what we want to do is really refocus prevention and treatment efforts into the longer term. We want, of course, to develop new medications that will initiate abstinence, but the critical thing in here is how can we build brain resilience mechanisms? The prefrontal cortex is really involved in resilience and in coping. And can we bring back the frontal systems as well as quieten the reactivity, emotional alerting system, which are in overdrive as a function of chronic drug use? And if we can rebalance that, then under conditions of stress, perhaps people have a chance to participate in resilient coping, regulate their emotions, increase behavioral control, increase attention and awareness, as well as begin to have some perspective and openness, and really shut down the connection or the tight control that stress has over the brains in early recovery. So with that, what I want to just leave you with is that, as Dr. Crystal said, that cancer has made a lot of advances in personalized medicine. And our goal is to really get to map that out, bring that to brain diseases and say, there's a lot of individual differences. Can we identify blood and brain biomarkers, which do better often than clinical markers, for those who are most vulnerable to relapse and recovery? And if we can do that, then we can begin to identify those right at treatment entry and target that to reverse the chronic drug effects on the early abstinent brain, develop specific mechanisms to restore brain resilient coping circuits, and to build long-term recovery. So with that, I want to just thank all of my collaborators over the years, the Yale Stress Center, which the Yale Medical School Department of Psychiatry has supported and established. This takes the work of a lot of folks. A lot of our work was done at the Clinical Neuroscience Research Unit, so the state Connecticut Department of Mental Health and Addiction Services supports that, and of course the National Institute of Health with grants. Thank you so much for your attention.